Good morning. This lesson is for my Integrated 1 classes, but before I get started, I want to say I hope that everyone is doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of are two goals for the day. Our first goal is going to be to recognize a pattern in a graph, and then once we take that relation, we're going to rewrite it in the table. I have a hard time speaking, sorry. Our second goal today is going to be rewrite the numbers in the table so that we get repeating numbers. So we are now going further with the concepts of relations. Remember, relations are inputs and outputs, and I can represent relations in multiple ways. I can represent relations as ordered pairs, a table, function notation, mapping diagram, and graphically. Now, sometimes we see patterns or something that's kind of obvious that there's something going on in one form or the other. Now, sometimes the best way to look at the information is a graph, which is what we have here. And so hopefully you recognize that the input and outputs make a pattern that represents a line. So the pattern that we recognize is a line. So our input and outputs are making a line. So that's the pattern we recognize. This is making a line. All right, that's what we need to understand. That pattern is linear, as we would say. All right, so what we want to do is we want to take the information that we have graphically and transfer it into a table. Now, let's see here. My first ordered pair, I have left or right movement of 0 because I'm on the y-axis, and I'm up 3. So my first ordered pair would be 0, 3. Okay. My second order pair, I have to come over 1, and I go up 5. 1 and 5. My third order pair, I go over 2 and up 7. So 2 and 7. And my last order pair, I go over 3 and up 9. All right. So let's look at this a little bit further before I end this part and come back. So since there's a pattern in the graphical representation of a relation, there should be a pattern in the table representation of the relation. Tongue twister. All right, so let's look at this, and I'll just go ahead and tell you what the pattern is. The y values are increasing by 2. And the x values are increasing by 1. So when I have this constant increasing in the x's and the y values, I'm going to have what we call a linear pattern, right? So I wanted to establish that a linear pattern graphically also has a pattern in the table. So there is also a pattern in the table, and it makes sense, right? So I'm going to go ahead and erase this and set up the second goal and show you how to rewrite the numbers in the table so that we get repeating numbers. So we're going to continue with this exact specific example. So let me clean all this up and I'll be back. I'm back. So let's go ahead and jump into our second goal. And our second goal is to rewrite the numbers in the table so that we get repeating numbers. Now I have some rules to help you rewrite the tables. The first rule is the top row stays the same. So 0, 3 will be in the new table because the top row stays the same. For the second example, 0, 20 will be in the second table when I rewrite the table of the repeating numbers because the top row stays the same. The second rule, the y value appears in every row. So when I rewrite this table, a 3 will be here, a 3 will be here, and a 3 will be here. And that ties into the third rule, which means values must stay the same. So I still have to have the value 5 when I use the number 3. I still have to have the value 7 when I use the number 3. And I still have to have the value 9 when I use the number 3. Same thing over here with 20. I still have to have the value 16 when I write a 20 in that row. I still have to have the value 12 when I write a 20 in that row, and I still have to have the value 8 when I write a 20 in that row. So, again, this is from the first example in the first part of this lesson, and let me remind you guys that this is changing at a rate of +2. Okay, so let's go ahead and rewrite the table with repeating numbers. It's pretty easy to do. It might take a little practice, but I think that it's like I said, it's a pretty straightforward concept. Okay, so when I write my new table, what I'm going to do is I'm going to make it a little larger than my previous table. First row will stay the same. The second row is going to be a little bigger. The third row is going to be a little bigger, and you'll see why here shortly. All right, so remember our top row stays the same. So this stays as a 0, 3. Our x values also stay the same. So 1, 2, and 3. Our second rule says the first y value appears in every row. So I need to put a 3 here. But I have to have the value 5. So I have to have the value 5 using the number 3. And I get the value 5 by adding 2 to my 3. Okay. In this row, again, I have to use the number 3. But I need to have the value 7. And in order for 3 to make a value 7, I have to add 2 twice. So this is going to be +2, +2. And finally, in order to write the value 9 using the number 3, I have to add 2. 1, 2, 3 times. So 3 is +2, +2, and +2. And before I go any further, remember this is a pattern. And if I have a pattern in the table, that means I had a pattern in the graph. And the pattern in the graph was it was making a line. All right, so I want to really reinforce that. Okay, so now let me show you how we write the repeating numbers. Well, these are technically repeating numbers, but those aren't the repeating numbers that we want. All right, so here we go. So I can say I have 3 + 2 or 3 + 2 times 1. Because I'm adding 1, 2 to my 3. And this is the repeating number that I'm talking about. We need a repeating number in the x and the y column. All right. Here I have 3 + 2 + 2. I have 2 of these 2's. So I could rewrite it and say 3 + 2 times 2. And again, here is my repeating number in my x and my y column. And finally, I can rewrite this as 3 + 3 2's. So this is 3 + 2 times 3. And again, I have a repeating number in my y and my x column. So this is all that I need you to be able to do from this lesson, is rewrite it like this. All right, here's another example of a table that I'd like you to rewrite with repeating numbers. Let's figure out how the numbers are changing first and make sure that we have a pattern that appears to be linear. So 20 turns into 16 by taking away 4. 16 turns into 12 by taking away 4. And 12 turns into 8 by taking away 4. So it would be a good idea for you to hit pause and try and rewrite this table so it's like that table. So hopefully you hit pause and try this on your own. Hopefully you hit pause and work it out. Last chance to hit pause because I'm going to work it out right now. And hopefully you did and you're back, or I'm back. Alright. So I'll write my table. First row is the same. Second's a little larger. Third's a little bit larger. Fourth's a little bit larger. Rule says first row stays the same. 0 and 20, and I have the same x values. I need to write a 20 in every row, and I still need to have the same values. So how do I get the value of 16 using a 20? Well, I have to take away a 4 from it. And I'm taking away 1 4 from it. So I can say this is 20 minus 4 times 1. All right. This row, again, I have to use a 20 in it, and I have to get the value 12. And the way that I'm going to get the value 12 using a 20 is I have to subtract 2 4's, which I can rewrite as 20 minus 4 times 2. And on the last row, again, I have to use the number 20 to write the value 8. And the way that I get the value 8 using the number 20 is I take away 3 4's. So 20 minus 4 minus 4 minus 4, which I could rewrite as 20 minus 4 times 3. And again, I want to highlight the repeating numbers because this is what we need. This is what we need for the next lesson. We need to have repeating numbers. There are my repeating numbers. And in fact, we technically have repeating numbers in the first row if I was just to write it like this. I'm not adding any 4, so I'm technically adding 4 times 0. And there is my repeating number in every row. So, hopefully this makes sense. I'm going to go ahead and end this here. Hopefully I'm also on the screen this time. This is why I'm redoing this lesson. And I am. Okay, good job. Alright. So, again, this is how we write our tables with repeating numbers. I'm going to go ahead and end this here. Again, I hope everyone is doing alright out there. Have a great day, everybody. Okay. Bye-bye.